I'm gonna start that recording real quick. So, so yeah, no questions. Everybody good? Yeah, yeah, sure. All right, go ahead, go ahead. Yeah. I didn't do class on Thursday night and go home again. Got you. I didn't know what to so I put up on yeah. I mean, today not gonna be too bad though, man. It's gonna be good. I thought the second test probably harder, but this one guy can't be calling. Yeah. We was good for one part, and then we got to early. I think, yeah, this next upcoming test is not gonna be bad at all. Especially if y'all use y'all calculators, y'all good. Just type it in, click enter, and that's it. I don't know why this thing is like so. Yeah. Yeah, we can go whatever you want. No pressure. Yeah. Oh boy, that be sitting in front of you, I'm forgetting his name. African dude. Alpha. Yeah, oh yeah, that is his name. He was the orange one too. Really? Oh yeah, oh, that's what's up. Yeah, he's really good in the class too. Yeah. Yeah. Yo. I like, bro. First thing he walked in, I was like, man, what is his name? I don't know, he racist. Yeah. They got a little short, little frozen table. Yeah. They say, yo, you still be with cotton? I was like, oh. Yeah. Oh. Nah, but this is a good school still though, man. Mm-hmm. Students over here that be studying the automotive tech, I'll be telling them about Morrisville. All right, Morrisville like that. Yeah. Bro, Morrisville, that's nothing about Morrisville. I was so lost. Yeah. Yeah. I wasn't criminal justice. That's why I need to get a degree in this place. Right, right. That's why when I got kids, I'm gonna tell them like, yo, you can go to college. If you play sports, you go to college for a break. But if you're not, you can probably take a year just to live. Yeah, what's up, man? You get a year to live. What the hell you want to do with your life? I didn't know what I would do out there. What I would do, I would say for your undergrad, right? I would aim to do something that's gonna give you a license, like what you're doing right now. Yeah, like you gonna get that certificate and be able to work. Like, yeah, just aim to do that. For master degree, if you want it, I would do something that ends in the word administration. Because I feel like with the master degree, you should learn how the business hierarchy works. So it could be business administration, public administration, anything, you know? Yeah. And then my mom so strict on me, but she always let me make my own decisions. Got you. She said it's strict. I mean, as long as you get it. Yeah. Sec. Second, you guys. Second. Franklin. Okay. You good. Hmm? Hmm. Green. Yeah. Okay. All right. All right. So did you find a question? Okay. Read it to me. Yeah. Sorry. All right, not bad. So here's what we got. We got 4s to the negative 2 power times t to the 6 raised to the 3 over 2 power over 8 s to the 6 t to the negative 3 raised to the 2 over 3 power. And then hold on, they want n t a over s to the b power. So they want n um they want n, they want a, and they want b. Okay. All right. So long story short, right? We want to apply this power, right, to every one individually. Mhm. I feel like this is the new homework. Am I right? Yeah. Which one? 0.3. All right. It's actually what we're gonna learn today. That's why it looks like funny. Yeah. All right, let's go through the lesson then. Let's go through the lesson. But this is real simple though. You're gonna see. That's perfect. Oh, that's beautiful. Finally. Okay. All right. Before we get into that, right? I want to do a little blast from the past real quick. Remember how to do this? I want to add two fractions together. In order to add them together, I have to find right. So what's the common denominator between 15 and 12? Three. Three? No, you gotta be something bigger. Right. There's got to be a bigger number that 15 and 12 could go into. You should do like 15 times 12. I could do that. It's going to be more work at the end, but yeah. So if I'm going to do that, say I'm going to multiply the 15 by 12. That's cool, but what I do to the bottom or I do to the top? And over here, I do the same thing. Multiply the 12 by 15. What I do to the bottom, I do to the top. Just like that. Then you just do the math out. Let me see. What's 7 times 12? 84. Okay, so we got 84 plus what's 5 times 15? So that's 75, right? All over whatever 15 times 12 is. Combine like terms, so I'm just adding 4 plus 5. Yeah. 4 plus 5 is like 9. 8 plus 7 was like 4. That's like 15, 159. Over to 15 times 12. Let me what I want to do. I want to find like a greatest common factor here. All right. Actually, wait, let me do the 15 times 12. Hold up. It's 180. So I got 159 over 180. I feel like 3 goes into 159. Let me see. Yeah, 3 goes into that, right? So if I divide 159 by 3, I get 53. Divide 1800, I'll get 60. So I'll reduce this to 60. Oh, excuse me, 53 over 60. And then I feel like this is it. Answer? Mm-hmm. Like, let's say we did the way you want to do it. We got that answer? Yeah. So what I would want is a number that 12 and 15 could go into. So 60 would be that number. And then, right. So then 15 would have been times 4, something like that. Yeah. And then what you do the bottom, you to the top, right? And then the 12 would have been, I think, times 5. And then what you do the bottom, you to the top. And you add them together, and that's it. All right. Same old, same old. You got the last of the past and next turn. Yeah. I got y'all, man. That exact one, though. Many different numbers. That's how. I promise you, this next one's gonna be light. How about this question? What do I do? We're gonna take the power and apply it to all of the terms, right? So we're gonna have like 4 to the third power times x squared to the third power times y to the fifth to the third power. So everybody, all the variables and the numbers inside of the term, they get that the power. So what's 4 to the third? Mhm. Good. Times what's x squared raised to the third power? No. When we raise a power to a power, what's the operation? Not adding, multiplying. X to the 6. Very good, right? This becomes x to the 2 times 3. So what about the y? Right. That's it. That's our final answer. 64, x to the 6, y to the 15. Questions on that? All right. How do I do this? Hmm? What, you just got to put in 5 times 5 times 5. Close. So with the negative, what does a negative do? I thought like, are they all negative fives now? Uh-uh. So what you do, right? You take it, you throw it into the denominator. So this becomes 1 over 5 to the third power. And yes, you're right. It becomes 1 over 5 times 5 times 5, which is 1 over 25 times 5. That's the answer. Oh, just multiply the 25 times 5. Final answer, yeah, 1 over, I think, 125. You just gotta do it like that, get rid of negative. Mm-hmm. You drop it into the denominator, get rid of the negative power. So questions on this? That's pretty straightforward. Good. All right. What we want to do is simplify expressions with a raised to the 1 over n. Rational expressions are another way of writing expressions with radicals. When we use radical exponents, we can apply the properties of exponents to simplify expressions. The power property for exponents says that a to the m, right, which is then raised to the n power, is equal to a to the m times n, right? Written, excuse me, when m and n are whole numbers, let's assume we are now not limited to whole numbers. Suppose we want to find a number p such that yp is raised to it. I'm sorry. Suppose we want to find number p such that 8 to the p power raised to the third power is equal to 8, right? We will use our power property of exponents to find the value of p. This is fun. This is dope. Check this out. Check this out. Check this out. All right. First, we have 8p raised to the third power is equal to 8. Whenever we raise the power to a power, we multiply. This becomes 3p. 8 to the 3p is equal to 8. After that, you have 3p. 8 to the 3p is equal to 8 to the 1, right? After that, you want to take the powers of the two exponents, so we get 3p is equal to 1. And then you want to solve for p, right? So dissolve by, excuse me, divide by 3 on both sides, you're going to get p is equal to 130. So write the exponent 1 on the right. Since the bases are the same, the exponents must be equal. Solve for p. So 8 raised to the 1/3 is raised to the third power. That's equal to 8. But we know that the cube root of the cube root of 8, excuse me, cubed is equal to 8. Then it must be that 8 to the 1/3 power is equal to the square root, excuse me, the cube root of 8. The same logic can be used for any positive integer n to show that a to the 1 minus n is equal to the nth root of 8. Questions? Are we good? All right. It'd be like eight things to be confusing, and then once you throw me out the code, then I get it. Got you. Got you. The rational exponent a to the 1 over n power. If the nth root of a is a real number and n is greater than or equal to 2, um then by definition a to the 1 over n is equal to technology. So that's rational exponent. So the denominator of the rational exponent is the index of the radical. There will be times when working with expressions will be easier if you can use rational exponents and limits when it will become a core. Excuse me. There will be times when working with expressions will be easier if you use rational exponents and times when it will be easier if you use radicals. In the next few examples, you'll practice converting expressions between these two ones. Okay. Notations. Let's try. All right. This joint right here, straight conversions. So I have x raised to the 1 over 2 power, right? Conversion. The denominator of the exponent is your radical. Numerator on the x. That's it. Let's try B. I have y to the 1/3 power. Denominator is your radical. Numerator on the y. Last week? No, that's this week. Yeah, that's all we're doing. Let's try Z. C, excuse me. I have Z to the 1 over 4. 4 root, and then Z to the 1. That's it. That's the whole concept. I don't want y'all to feel left out, so you guys try. Just to make sure that we got this. Good job. Oh, that wind, yeah. Got you. But this not even cold though. This is just like, yeah. My body not built like that shit no more. Got you, got you. Yeah. Yeah, Morrisville is cold. Hell yeah, upstate. Yeah. Imagine having a car, can't even use it. Yeah. Especially if you have one of them low cars, that's like low to the ground. Yeah, yeah. Yeah, you got to be on some SUV type thing. But you They got these new type of SUVs. I don't know if the right word is crossover or convertible or something, but it's like small. Like they're not as big as they used to make them. Yeah. But you could do some crazy turns in that you couldn't do in the old SUVs. Old SUVs will turn over with you. Yeah. Wow. Yeah. Oh yeah, so it's definitely cold there. Yeah. Yo, Florida be scaring me though, man. Because one minute it's the next minute like, yo, we got a hurricane coming. It's like, oh, that hurricane season crazy. Yeah. Well, I remember my first hurricane season, boy, I was panicking. Like, man, you gotta put some boards on your window, you'll be all right. Boards on your window. Yo, Home Depot or something. Yeah. 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 Shit, I was there. We had three hurricanes. Only one of them was like pretty bad. Yeah. The other two, because I didn't live in I was by the border because it's Florida, but yeah, I was in North Florida. I was in Jacksonville. I should there in the border. Mm-hmm. For bombs. Mm-hmm. All right. So let's look at this. So I want to write this as a radical expression, right? Let's take A for example. T to the 1/2 power. What's that gonna become? T2 and the little thingy. So square root. Square root 2. And T to the 1 power, right? Well, you gave us homework and test questions. Yeah. Nah, I'm lying. She's asked for a question on homework. Nah, that's deeper. That's deeper, yeah. Because we doing like two sections. That's like the first section. Most of the homework is like this. When you go into homework and you see like mad questions, like double digit questions, it's mad easy. Yeah. Man, there was one work I was stalling. I had to do it last week. Yeah. But it was mad easy though, right? It was mad work. It was I understood what I was doing. It was mad like breaking down. Yeah. All right, look. What's this one gonna be? Same shit. 3 square root. Cube root. Uh-huh. And then M to the 1, right? M to the 1 part. All right, let me try this next one, right? So I got C. She got answer next. All right. I got R to the 1/4 power. What's that? Uh-huh. Fourth root. And R to the 1. Perfect. Yeah. All right, that's not bad. That's not bad at all. Let's take it up a notch real quick. So I'm about to ask you the reverse question right now, all right? Reverse question. So I want to write this as a rational exponent, all right? So you see like how we have the radicals right here? I want you to give me back an answer, right? It's going to be raised to a power. So for example, right? Hold on one second. So for example, right, A is the square root of 5y, right? We're going to convert this. This is going to become open parentheses 5y. Now 1 over 2, right? When you don't see a number there, there's an imaginary 2 there, right? So 1 over 2. Let's look at B. Oh, that's the answer? Yep, that's it. That's all I'm looking for. No, you got to make a parentheses there? Mm-hmm. Yeah, so open parentheses, whatever, close parentheses, and then raise it to the power. Yeah. No. It has to be raised to the power. But there's a button there on the homework that raises to the power for you. Like it looks something like this. Like yeah, something like that. Yeah. All right, so look, I got the cube root of 4x. This is gonna become what? 4x raised to the 1 over 3 power. That's it. All right. Yeah. I'm gonna go purple for this one. How about C, right? I got 3/4 root of 5z, right? It's gonna no, it's gonna be 3 open parentheses 5z raised to the 1 over 4. That's it. All right. So we basically changing the radicals into the fraction powers. That's all we're doing here. All right, you guys try. And keep it simple.
He felt everybody panic.
For what?
Life.
Yeah.
Oh, yo, I got like three friends like y'all about to drink a fucking army. I'm like, man, I feel like the army's a cop out though. Like we ain't tried.
I mean, if it's like you if you come from like an army like family type joint.
25 years old, they trying to check.
Oh, I
They ain't
see.
trying to know what they is, man. They go to
But yo, but don't the army got an age limit though?
28, I think.
Or the 28? Okay.
I think so. Like it's just like, you know what it is?
Mm-hmm.
I don't know who moved down to Florida. I think that shit no way. Ain't know the crazy part about that shit?
What?
The main reason why I was able to pull that shit off,
Yeah.
not that money. So I didn't need to worry about working because I kept having money.
Right.
So I had time to figure shit out.
Right.
Don't get me wrong, the way we did it was horrible.
Mm-hmm.
Shit, I don't care that I don't
Yeah.
secret my car. We done that shit out.
Damn.
Like I was on some shit like, man, y'all gonna got me down here, man. We gonna figure this shit like
Right.
drove all this shit. Man.
Yeah. Yeah.
We did. But now I know the blueprint.
Right.
Also $4,000.
That's it?
You need a down payment,
Yeah.
first month rent, maybe extra 2,000 a living until you get a job.
Okay.
You did it. And then after that, you just slowly build up, you get furniture, and then
But 2K is good enough for like a it's good enough for like 6 months or 8 months?
2 man's probably get you the first one, get you in. But let's say like my rent, I had a 3-bedroom house in my yard. I kid you not. I'll take pictures of it.
Yeah.
My yard was bigger than this classroom.
That's fire.
Way bigger. I mean, like way bigger. I mean,
Yeah.
I had dogs. Y'all no longer households. Because when I first lived here, I had an apartment. We got an apartment.
Yeah.
And we opened our own ways because you stacked money.
Right.
Like 1,300 a month.
Yeah.
Had 3 ways.
That's not bad.
Boom, boom, boom. Like,
Yeah. Yeah.
Then I got my own place for like 1,500 a month. I was really chilling. I was like, I lived, if that house was in Virginia or something, I would still be here. I got too far from home.
Got
So
you.
let's say 1,500, you got the down payment was 3,000. You got it.
Oh yeah, first month, last month, yeah.
Then after that, you pay that 3,000.
Yeah.
Shit, you got to multiply some fucking money. That's why I say you go down there. Let's say you want to be safe, go down there for 5,000.
Yeah.
Bro, they hire like it's not like here, they hire.
Yeah.
Like all you gotta do, let's say like me personally, I'll go down there, or wherever I go, get my 5,000, boom, I'll go right to Allied University.
I would say like yo, do 6 months, 6 to 8 months, like emergency fund, and then go and then make the move.
Yeah, right, just to be safe.
Yeah. Because you never know.
Oh God, she'll cover it. My mom got mad, right?
So you good.
Yeah, I'm good. She'll cover it. Like, if I tell her, move, shit, she's gonna send me like $300.
That's nice. That's love right there.
Shit, it is and it isn't.
Yeah. Man.
Like, that's why I don't be panicking. Like, a lot of them, they don't know what the world is like outside of here. New York is like a this stuff fucking live. Right? These motherfuckers, man, ticket. But I heard about charging you go to Manhattan now.
Oh yeah, the congestion pricing. Yeah. What's next level?
Then I'm like, man, I'm about to move to Jersey. Oh, man, I gotta take
Yo, Jersey got it worse though, because they got the highest property taxes in like the country. I might be wrong. It might be like the second highest, but it's high. You know?
Look, they never bothered me.
Yeah.
That's why I got the wrong way process for the Philly. I don't see what Philly's like.
Nah, you know where it's real nice? Connecticut.
I mean, look, low prices. I want low prices for nice shit. You can get the nicest house in the middle of fucking. Oh, my God, in the middle of the.
Yeah.
Because like, okay, I'm in a little bit of shit. My shit, you know.
Now
she doing the projects. Like projects is disgusting. When you walk in her house, you don't feel it. Right?
You know what's real nice though? They got a place in the Bronx called Country Club. Go check that out.
Where's that?
Google it. I don't even know. Google it.
I feel like that shit near co-op.
It is.
Yeah, I know. I feel like I know what you're talking
It is.
about.
Google it.
But you know, it's expensive. Bro, is literally double what I was paying for a house.
Damn.
2,200 for a three-bedroom apartment. Or I was paying 10 for a three-bedroom house. Like, it doesn't make sense. Like, bro, once I see something a certain way, that shit don't make sense for me.
It's the location.
It's like I'm saying, because like I know why it is the way it is, but for me to do it, oh hell, it doesn't make no sense.
They got some other places around here that's not so bad though.
I'm gonna pay. I'm gonna pay.
But you drive if you driving, man, I'm telling you, Connecticut, it's not bad. Yeah. All right. All right, check this out real quick. So look, we got square root 10m, right? It's just gonna be 10m 1 over 2 power, right? Let's try out that b real quick. This b gonna be real nice. We got the fifth root of 3n, right? So what that gonna be?
You just put the 5 first? No,
Yeah. 3n
and 1/5. Right?
And 1/5. That's it. All right, let's try another one though, right? This one gonna be a little bit harder. I'm gonna try this one in black, right? This was C, right? I got the fourth root of 6y. So you already know, right? That's gonna be 6y raised to the 1/4. And then that's it. Good stuff, good stuff, good stuff. So we know how to go both ways, right? Now, let's take it up a notch, right? Let's forget about them those what you call it variables, right? Let's put in some numbers. So check this out. This might look crazy, but low key, you know what this is already, right? Let me check out A real quick. This is A, right? I got 25 to the half power, right? You know what that is. That's just the square root of 25. And what's the square root of 25? Exactly. That's all it is, right? Let's try out B. For B, I got 64 to the 1/3 power. You already know what that is, right? That's the cube root of 64, not 8. Excuse me.
Square root is like 5 times something.
Well, this one's the cube root. I feel like it's like 4.
4 times 4 times 4, right?
Right.
Yeah, probably.
It's 4 times 4, 16. 16 times 4, right? That's 64, right? Something like that. How about C? A little bit harder. I got 256 raised to the 1/4 power, but you already know what that is. That's going to be the fourth root of 256, right? Hey. So 256, let's think about that. What could that be? Could that be 3? I don't know. Let's see. I got 3 to the 4. Nope, it ain't 3. About 6, maybe. It ain't 6. It's got to be 4 too. That's it. 4.
That's impossible to figure out. How would you even go about figuring that?
So what I'm trying to figure out when I do that is what number multiplied by itself 3 times will give me that. Low key, most of the time I don't know the answer. Like with 256, I didn't know the answer. To be honest with
4
you.
times 4 times 4 times 4, you still get it?
Yeah. So here's how I would do it. You can. Yeah, the calculator give it to you straight. Oh yeah. No problem. No problem. You're fine. So let's say I'm in a situation, right? And like keep it 100. I don't know how to do it, right? Use a Now use a prime factorization. You got the 256, right? Whoops, 256. I'm sorry. Right? Find two numbers that multiply to give you 256, right? Exactly. That's the easiest thing to do, right? So we have two. We know what that is, right? Cut this in half. That's like what? 125 and 3, right? So that's like what, 128? Yeah. 128, right? And then just keep going. Cut that in half, right? This is gonna be like what, 64? And just cut that in half. This is two, that's 32. Cut that in half. This is two, and that's like what, 16? Am I right about 15? Yeah, 16. You already know, right? Could cut that now. Four and four, and you already know. Two, 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 two. And then you just count them. I have, how many twos do I have here? One, two, three, four, five, six, seven, eight, right? So I could say that this is the fourth root of 2 to the eighth power. See that? And then flip this back. This becomes what? 2 to the 8 over 4 power. Call that 2 to the second. Call that 4. Same 4 here. So that's how I do it. Yeah. Well, that's because I don't know my timetables that great, like y'all, you know? So I gotta be doing things like this. But you guys try. Nothing too crazy. Try those out. Think so?
Yeah.
All right, so this is a little bit tougher. What y'all think? We know we want 100 to the half power, and we know that that means that it's the square root of 100, which is what? Very good. All right. And then for B, right, I have 27 to the 1/3 power, which we know is the cube root of 27, which is what? Who is it? 3, exactly. It's very good. And then for C, I have 81 to the 1/4 power, which we know is just the fourth root of 81, which is equal to what? 9? Not 9. Mhm. 4? Not 4, no. What's 27 times 3? All right. So 3. All right. And there we go. This is pretty cool. Pretty cool. All right. So I just want to make a special note real quick. Special note. Make that a little bit bigger. All right. So be careful of the placement of the negative signs in the next example, right? So we will need to use a property that a to the negative n power is equal to 1 over a to the n, right? So negative exponents, just throw them into the denominator, right? And then just treat them like they were positive exponents, but they're being divided by, or they're underneath 1, right? Let's take a look. Let's take a look. Let's take a look. So I want we're gonna do I have negative 16 to the 1/4 power, which we know is the fourth root of negative 16, all right? So what's the answer here? Not negative 16. Mm-mm. Not 1. What's the answer? All right, I like that.
Yeah,
Elaborate.
Like,
I'm fourth rooting it. Yeah,
gangster.
not quite 2. Mhm.
Two is eight.
Uh-huh.
8 times 2 is 16.
But what happens when I have a negative?
Like,
Nah. What do we say? What happens when we have the negative? Mm-mm. All right, it's not real. That's the answer.
Jesus.
Yeah, you remember that? Yeah,
Negative is not real.
right.
All is not real.
But for the B, B is a little bit different though, because look at this. B is negative 16 to the 1/4, right? So we know that that's the negative fourth root of positive 16. That is 2. So your final answer here, this is negative 2. See that? Yeah. So we have negative 16 to the 1/4 power right here, right? We know that's going to be negative fourth root of 16. And the fourth root of 16, as you said, is right. That's negative 2. Right? Just keep the negative on the outside. Hmm? Yeah. There's a difference in all of them. So now look at C now, right? C's a little bit different. Check out C. C, I got positive 16, but I'm raised to the negative 1/4 root, right? So watch what happens with this now. I'm gonna take, right, the 16 to the 1/4 root power. I'm gonna put it in the denominator. So this is gonna become 1 over 16 raised to the 1/4 power, just like that. And we said 16 to the 1/4 power, we said was 2, right? So this becomes what? 1 over the 4th root of 16, which is going to be 1 over 2. And that's it. Questions on this? Does it make sense? Okay. You guys try. Try that out. Try that out. All right, let's take a look. Damn. They look crazy as hell, man. We got -64 raised to the negative half power. That's a double negative. So you already know what's going to happen, right? This going to go in the denominator. So I got the -64 raised to the positive half power, right? But what happens when I take the square root of a negative number, right? It's not real. Imaginary. Can't work with it, right? What about B? I got that -64 to the half power. You already know what that is. That's going to be negative square root of 64. And square root of 64 is what? It's just -8, right? Whoops. I'm about to give y'all an infinity sign. My fault. And then let's look at C. For C, I got that 64 raised to the negative half, right? So remember, that's going to drop down into the denominator, like so. This is going to become 64 raised to the positive half in the denominator. And then you know that that's just 1 over the square root of 64. And the square root of 64 we know is just 8. So 1 over 8. Questions about this? All right. That sounds good. So let's take this up a notch then. All right. Let's take this up a notch. Oops. So the next thing I want to do is I want to simplify expressions with a to the m over n powers, right? So we look at a to the m over n in two ways. Remember, the power property tells us to multiply the exponents, and so a to the 1 over n raised to the m power and a to the m power raised to the 1 over n power both equal a to the m over n power. If we write these expressions in radical form, we get a to the m over n is equal to a to the 1 over n raised to the m power, or we could say the nth root of a raised to the m power. And we could say a to the m over n power is equal to a to the m raised to the 1 over n power, and the nth root of a, the nth root of a to the m power, right? Vice versa. This is really good to remember. Yeah, I know I like to repeat myself, right? So let's do it one more time. So I have the rational exponent, right? A to the m over n power. So for any positive integers m and n, a to the m over n is equal to the nth root of a raised to the m power, and a to the m over n is equal to the nth root of a to the m power. All right? Vice versa is true. All right, so which form do we use to simplify an expression? We usually take the root first. That way we keep the numbers in the radicand smaller before raising it to the power indicated. This is a really important point. You guys should take this to heart, right? We usually take the root first. That way we keep the numbers in the radicand smaller before raising it to the power indicated. Give you guys an example. So let's say I want to do this, right? It says write with the rational exponent, right? So the square root of y to the third power, right? Looking at A. Right? We know that's going to become what? That's going to become y to the 3 over 2 power. right? Let's look at B. I have the cube root of 2x and then raised to the fourth. Right? So we're going to change this to be 2x raised to the 1/3 power, which is then raised to the fourth power. Right? Whenever we raise a power to a power multiplies, this becomes 2x raised to the 4/3. Questions on that? Make sense? Let's look at C. So for C, I have the square root 3a over 5b. Apologies. That's cubed. Let's make it raised to the same power. This is going to be 3a over 4b. Sorry, raised to the 3/2 power. And that's basically it. Questions on that? Just rewriting it, make it look nice. You guys try. Try these out. All right, let's take a look. For A, right? Square root x to the fifth power. This is just x to the 5 over 2 power. B, fourth root 3y raised to the third power. This is what? 3y raised to the 3 over 4 power. C, square roots of 2m over 2n. Sorry, to the fifth. This is going to be 2m over 2n. Excuse me, why is he saying 2? 3n, it's just 3, right? Raised to the 5 over 2 power.
It doesn't matter if three is over that, three is in the bottom and four is on top.
Not really. Same thing. So that's it. Questions on this? Okay. Just gonna make a special note. Remember that a to the negative n power is equal to 1 over a to the n. The negative sign of the exponent does not change the sign of the expression. Okay? Let's try this. So for a, I have 125 raised to the 2 over 3 power, all right? What I want to do, I want to take the cube root of 125, or whatever that answer is. I want to square that, right? So always do your roots first before you do your other squaring. What's up? Okay. So the cube root of 125, what's that? Like 5, right? Now we're gonna square that 5 to the second, call that 25, and that's it. Not too bad, not too bad. Let's take a look at B, right? I have 16 raised to the negative 3 over 2. You already know what's gonna happen. This is gonna become 1 over 16 to the 3 over 2. And then, like I said, do the root first before you do the power on the outside, right? So this becomes 1 over the square root of 16 raised to the third power, and the square root of 16 we know is what? 4, right? So this is 1 over 4 to the third, right? And that's gonna be equal to what? That's trying to think, 16 and 4, 64. And that's it. Let's keep it going. For C, I got 32 raised to the negative 2 over 5 power. All right? This would be the fifth root. And then we have raise this to the -2 power. So fifth root of 32 is what? Yeah. So that's about 2, right? So this is going to be 2 to the -2 power, which becomes 1 over 2 to the second. Call that 1 over 4. And that's it. Questions on this?
See how you did V, instead of like doing things just in a fraction, and what's the difference between B and C?
Got you. So same thing. I should have probably put that in the denominator first. That's the only thing for C.
Oh, you just.
Yeah, it just happened that way. I wasn't thinking. But yeah, the first thing you should do with the negative, drop it down to the denominator, make it positive. Do the root first, and then you could raise it to the power afterwards. So that's a trick right there. You're welcome. Anytime. You guys try. All right, let's keep this. All right. So I'm gonna look at A. I got 27 raised to the 2 over 3 power. You already know, right? I want to do the cube root of 27 and then square it. So what's the cube root of 27? 3, right? This becomes 3 and then square it. So call it 9. All right. Not too bad, right? B, I have a negative power. This is 81 to the negative 3 over 2. So you already know, right? I want to drop that in denominator. This becomes 1 over 81 to the 3 over 2 power. And then this is going to be 1 over the square root of 81. Then you're going to cube it, right? This becomes 1 over square root of 81, we know is 9, right? So this is just 9 to the third power, which is, what's that? What is it? 720, 729 or something like that. I might be wrong. Let me check. This is 9 raised to 729. All right. All right, that sounds good. Let's look at C real quick. Not too bad. I got 16 raised to the negative 3 over 4 power, right? So remember, I want to drop that down in the denominator. So 16 to the 3 over 4. I want to do the fourth root of 16. So what's the fourth root of 16? The fourth root of 16. 2. And then we just have to cube that, right? So 2 to the third power is what? 8. And that's it. Questions on this? Nope. That sounds good. Let's look at another example real quick. All right, so let's look at A. So for A here, I have negative 25 raised to the 3 over 2 power. So you already know, right? Keep this negative. We're going to do square roots 25. And then what I want to raise that to the third power. Call that what? 5. So this becomes negative 5 to the third power, right? Which is like what? Negative 125. Make sense? All right. We'll look at B. B, I have negative 25 raised to the negative 3 over 2 power. So you already know what's going to happen here, right? I'm going to throw this down in the denominator. This is 1 over negative 25 to the 3 over 2 power, like so. And then same game as I did up top. This is going to become negative 1 over square root 25 raised to the third power. This is going to be negative 1 over 5 to the third, which will become negative 1 over, what is that? 225? 125, right? That sounds about right. And that's it. Look at C. I have -25 raised to 3/2. This is going to become, right? We're going to do -25 raised to the half power. The half power, because that's the denominator. Over there, that's going to be our denominator. Hold on. Do the radical. That's better. And then raise that to third. But help me out though. Square root of a negative number is not real. So that's my final answer right here. So anytime you're trying to take an even root of a negative number, it's not real. All right. Even on your homework, that's what you're going to write in, not real. Unless they tell you something else, like any or something like that in the instructions. All right. Try this out. Take a look. For A, -16 to the 3/2 power. I want to do the square root, -16, and raise that to the third power. Hold up. I want to do negative, open parentheses, the square root of 16, raise to the third power. And the square root of 16 we know is just 4. So this is -4 to the third power. Right? 4 and 4 is 16. 16 times 4, what's that? 64. So negative 64 is our answer. Those parentheses things matter. So now I have negative 16 raised to the negative 3 over 2 power. So this is still negative, but this is going to be 1 over the square root of 16 cubed, which becomes negative 1 over that 4 to the third, right? And then this is negative 1 over, let's see, 4 and 4 is 16. What's that, 64? You can see I have negative 16 raised to the negative 3 over 2. All right. This is going to drop down to the denominator. Right? And then I want to do square root. And my answer is not real. I'm trying to take the square root of a negative number there. Questions on this? For now, I want to use the properties of exponents to simplify expressions with radical exponents. The same properties of exponents that we have already used also apply to rational exponents. We will list the properties of exponents here, right, to have them for reference as we simplify expressions. So this is all on your formula sheet, but we're going to take a look. So here you go. These are the properties of exponents. So if a and b are real numbers and m and n are rational numbers, then the product property says that a to the m times a to the n is equal to a to the m plus n. So when you multiply exponents, you add the powers. The power property says that a to the m raised to the n power is equal to a to the m times n. So when you raise a power to a power, multiply. The product to a power states that a times b raised to the m is equal to a to the m times b to the m. The quotient property says a to the m over a to the n is equal to a to the m minus n power, right? The zero exponent definition, a to the 0 is equal to 1. Anything to the 0 power is 1. The quotient to a power property, a over b to the m power is equal to a to the m divided by b to the m. And a negative exponent property, a to the negative n is equal to 1 over a to the n. Questions about this? Same rules as before. Let's try this out. So number one, A, is x raised to the 1/2 times x to the 5/6. You already know I'm gonna add these, right? So this becomes x to the 1/2 plus x to the 5/6. So multiply this by 3, or we do to the bottom, do to the top. So 3 plus 5/6 divided by, whoops. Sorry, this is x to the 3 plus 5/6. 5, 6, 7, 8. So this is x to the 8/6. And that's it. B, z to the 9 raised to the 2/3 power. This is like saying I have z to the 9 So this is like 9/1 times 2/3. And multiply straight across. We're gonna have z to the, what's that? 18/3. I can reduce that a little bit, right? That's like 6. Not bad. C, a little different. X to the 1/3. Five over three. So we have x to the 1/3 over x to the 5/3, right? I want to simplify this, so we're going to subtract them, right? So this becomes the x to the 1/3 minus 5/3, right? Call this x negative 4/3. All right. That's it. If you want to drop that in the denominator for web work, call it a day at that. Let y'all try one. I'm still working up to the question that we got asked earlier in the beginning of class. Let's look at A. I have x to the 1 over 6 times x to the 4 over 3. Whenever we multiply exponents, we're going to add them. So this becomes x to the 1 over 6 plus 4 over 3. I'm going to multiply this 3 by 2 to get the LCD, or do the one side, do the bottom, do the top. This becomes x to the 1 plus 8 all over 6. Let's call that x to the 9 over 6. Are we good? If you want to reduce it a little bit, call it x to the 3 over 2. And that's it. For B, I have x to the 6 power raised to the 4 over 3 power. This is going to become, whenever you raise a power to power, you multiply. So x to the 6 over 1 times 4 over 3. 3 goes into 3 once, 3 goes into 6 2 times. Let's call this x to the 8 power. All right. Let's look at C. I have x to the 2 over 3 divided by x to the 5 over 3. Right? So whenever I divide exponents, I'm going to subtract. So this is x to the 2 over 3 minus 5 over 3, which is equal to x to the negative 1. So call that x. Call that 1 over x. Questions on this so far? All right. Special note. Sometimes we need to use more than one property. In the next example, we will use both the product to a power property and then power property. All right? So we're going to combine two of these rules together. Let's take a look. This might look crazy, but we know what to do here. All right? Everybody individually. I'm looking at A, right? So this is going to be 27 to the 2 over 3 power times the U to the half power raised to the 2 over 3 power. All right? For the 27, you already know. Do the cube root of the 27 and then square it. For the U, right? We know that we're raising a power to a power, so we're going to multiply. So this is going to become U to the 1 times 2 is 2 over 2 times 3, 6. All right? Cube root of 27 is what? 3. So this becomes 3. Hold up. There we go. This becomes 3 squared times U to the 1 over 3. Final answer, 9U to the 1 over 3. Questions?
Maybe write it out like that instead of just doing it.
So I want to do them individually. Like U to the 2/3 and then to the half. It doesn't matter, right? Yeah, because whenever you raise a power to a power, you just multiply. And the way we multiply the fraction is straight across. So 1 times 2, 2. 2 times 3, 6. And then you just reduce it to 1 over 3. Yeah. All right, let's take a look at the next one, right? I'm gonna just put a line down here. I'm gonna just do B over here because of the spacing. So remember, individually, right? I have M to the 2 over 3 power. I'm gonna raise this to the 3 over 2 power times N to the half power I'm gonna raise that to the 3/2 power. Right? So whenever we raise the power to power, we multiply straight across. This is gonna become m to the what 6/6 power times n to the 3/4 power. This is gonna become 1, and then we're gonna have n to the 3/4 power. Times n to 3/4. All right. Questions on this? Just combining our rules. You guys try. All right, let's take a look. So remember individually, right? I want to take that 32. I want to raise that to the 3 over 5 power times. I want to do the x to the 1/3 and raise that also to the 3 over 5 power. This is going to become the fifth root of 32 cubed times, right? This is just going to be the x to the 1/3 times the 3 over 5. Because whenever we raise a power to a power, we multiply, right? Fifth root of 32, what's that? Like 2, I think. Yeah. So this is going to be like 2 to the 3rd power times x to the, multiply straight across, 3's will cancel, 1 over 5. Call that 8 x to the 1 over 5 power. And then that's it. Questions on that? I'm going to just put a line here. Let's do the other one, right? Individually. I got x to the 3 over 4 raised to the 2 over 3 power times y to the half raised to the 2 over 3 power. Again, just multiply straight across, right? This is going to become x to the 3 over 4 times 2 over 3 times y to the 1/2 times 2 over 3. Simplify this. This is 2. This is 1. This becomes x to the half power times y to the 1/3 power. And that's it. Questions? All right. Let's do a super duper duper problem right here. This is more like what the homework's going to be like. Damn. It might look crazy, but we just combining a whole bunch of lessons together, right? One shot. It's not too bad though. Let's look at A. I have x to the 3 over 4 times x to the negative 1 over 4 all over x to the negative 6 over 4. All right, real quick. If I'm multiplying exponents, what am I going to do? Add them, right? So we already know. I'm just looking at the top, right? I'm just go straight across. This is going to become x to the 3 over 4 plus negative 1 over 4, right? All over x to the negative 6 over 4. Now they got the same denominators. I could just add straight across. So 3 plus negative 1, that's just 2, right? This is going to become x to the 2 over 4 over x to the negative 6 over 4. Now, when I'm dividing exponents, what do I do? Subtract. So this becomes what? X to the 2 over 4 minus negative 6 over 4. A negative and a negative is a positive. So this becomes x to the 2 over 4 plus 6 over 4. Let's call that 8 over 4. So this becomes x to the 8 over 4. Let's make our life simple. Call that x squared. Done. Not so bad, right? Just combining rules. That's all that is. Let's take a look at the next one. Oh my God. I'm gonna have to like cut and paste that one. Yeah. I'm gonna just have to cut and paste this one. That one is brolic. That one deserves its own little stage right here. Oh, let's take a look at that real quick, right? Easiest way to do this, simplify the inside first, then work on the outside, right? So this is going to be the same 16 right here, right? Remember, whenever I'm dividing exponents, I'm going to subtract, right? So I'm going to keep the 16. This is going to be x to the 4 over 3 minus negative 2 over 3. Now we're going to have the y, which is going to be negative 5 over 6 minus 1 over 6. And of course, all of that is raised to the half power. All right? So this is going to be what? 16. X, negative is positive. 4 plus 2, what's that? 6 over 3. Y, negative 5 minus 1, that's like negative 6 over 6. Of course, all this is raised to, I think, the half power, if I'm not mistaken. Good. Let's keep it moving. This is 16 x squared, y to the negative 1, raised to the half power. I put the half power on everybody. So this is going to be 16 to the half, x squared to the half, y to negative 1 to the half. All right, so square root of 16 we know is 4. This is just going to turn into multiplication, all right? So that's just like plain x. And then this 2 is also multiplication, so that's going to be y to the negative half. And then you know I'm not allowed to have negative exponents, so final answer, 4x over y to the half. And then that's it. Questions on this? We good? Yeah. It's mad rules, but like they just repeat, you know? All right, let's tap out at that. Let's call it a day. Yeah. All right, so catch up on the homework, knock it out. We do have more stuff to do, so I think one of the homeworks that you guys have access to right now, we didn't cover that yet. We'll cover that next class. All right. So you should be able to at least do this one. I think this is like 8.2 stuff. You're welcome. See you. All right. Not too bad, not too bad. We'll pick it up on Thursday online. All right. All right. You too, man. Have a good day. I'll see you, man. All right. All right. Catch up with you.